All right. What's up, everybody? We're going to do a RP2040 development stream. We're also going to review PRs, do some scripts, kind of the deal. Let's see. I think there was one thing I wanted to review to get us started. Yeah. Unstarring. So somebody implemented unstarring. We only had starring. Then I asked this person to implement some snapshot tests. So remove star button. Doesn't really look like button has star text expect page dev star button has text. Remove star. It's close, but if the what does GitHub do? But if the snippet is starred, you should say starred in. I don't think this he's saying the bun tests are failing. That thing, it's not his fault that the bun tests are failing. True. We're not running tests against main. That's unfortunate. Test pass on main. On pull request, on push. Yeah, branches. I feel like this cursor update thing has been popping up for days. I don't know how to make it go away. The RP2040 is a small Raspberry Pi chip. It's kind of like their embedded offering. They have 2 or 3 chips that are notable in the embedded offering. If you don't want, like, I guess everything's embedded, but if you don't need like a full computer, this is like, you know, a microcontroller. So it's like much smaller, much cheaper. I don't know what the normal Raspberry Pi chip is. Like if you want a normal Raspberry Pi processor, can you buy that? Is there a chip? Like what chip is on a Raspberry Pi? I don't think they use their own silicon. Maybe they do. What processor does a Raspberry Pi 5 have? Yeah, Broadcom. So they're new to the chip game and they're not making full processors yet. Although the knowledge cutoff is kind of late. Next, Perplexity. I never use Perplexity, but people swear by this. So an ARM processor. It's got to be a little bit awkward when you're kind of competing against your vendors because they have to buy chips on one side But their latest chip, the RP2035, RP30, shoot, new Raspberry Pi chip. What is it called? Not RP2350. That one is like starting to get more competitive. Yeah, so we're using the RP2040 because it's way more stocked. It's probably gonna be cheaper too. But okay, so this has got a Cortex M33 core with a RISC-V core, RISC-V core. I don't know, maybe doesn't have high-speed USB. So it looks like it's still, too limited to use for, I don't know, something with a UI, maybe? I wonder if that's fair to say. This is also, like, I'm not really tracking the Cortex cores. I have no idea what this means. It's so easy to go down hardware rabbit holes. It's crazy to me. Or maybe, it's easy to go down front-end rabbit holes, but I feel like I've been down most of them. I haven't gone down the Svelte hole. Never tried too hard to get into Svelte. Because like with React, you have multiple targets. So I was like, wow. It's like learning a general purpose language, right? Because you have native mobile development, stuff like that. You don't have that with Svelte native. Okay, maybe you do. But it could be like Flutter, where Flutter was like super crappy for mobile apps for a really long time. My knowledge is all dated, by the way. I do wonder why they say RP2040 is a hobby chip. Is it just a lack of security? There's probably some like, it's like anything else. There's like enterprise requirements. All right. Let's get into it. So I think what I'll do, I'll close a bunch of stuff. By the way, if you do have code reviews, drop them in Review Me. I'll have that on my other screen, so I can check it out if you drop something. Man, last night I set up caching for the JLC, the unofficial parts engine JLC, and it's barely noticeable because it was already pretty fast, but I feel it super fast now. What makes me excited about this having a Cloudflare caching is I don't have to worry about like server load or anything like that, because there's not that many unique pages. So it's like the server can handle new entries, but it probably wouldn't be able to handle if a bunch of people went to it. And it has an API, so I want to be able to hit that API pretty hard and not have to worry about it. And so I think I have that now. It did take me a while. I had to argue with a bunch of people. I was a bit rude, I would say, on the live forum, if anybody responded to me. I was like, why isn't this working? And it was all my fault, as usual. Configuration issue. Anyway, we need to string up this resistor array. Whoops. Left half. Then we'll open up TS circuit. It's on the right half. We might change that up. Yeah, maybe we... Then let's close other tabs, keep this nice and simple, because it's going to get complicated. So the first thing is, I remember this from yesterday, man, this search box Um, so I realized yesterday when I look at the top of this, or maybe the bottom. No, actually, I guess yeah, the top. It's missing like IO VDD, like all of them. And these are also kind of spaced a little bit hard to understand. You know, yeah, it's just kind of messed up. So yeah, this is going to be probably the hardest part of the schematic to translate because I have a bigger board that I'm using this chip for. But the Raspberry Pi essentially has like tons of these IOVD pins. And so we have duplicate pin labels right now, but I think we actually want them to be individual so that we can say, okay, we're going to link this particular capacitor to this particular pin, which I think is what they want you to do. But I'm going to have to read this reference to figure out what exactly is going on. Yeah, this is why I was worried about using the RP2040, is there's just a ton of capacitors. Okay, so they're still not showing up because we need to change schematic board arrangement. For people who like are using or want to use TS circuit but are intimidated by like this side, chances are you probably won't have to do this. Like I'm building modules for people so that they don't have to implement reference schematics, but somebody has to do it once. So looks like there's also multiple DVDs. I don't know what that one is. DVDD. Okay, so call it DVD 1 and DVD. Right. Then down here we'll say 1, 2. I actually had this generated by AI, so it's kind of interesting how right it was and how it got a bunch wrong as well. So if we want to arrange it the same as our diagram over here, it's probably best practice since this is the official Raspberry Pi hardware design document. Vreg V out, reg IO VD. Pin 44. I wonder if there's something that doesn't match there. Yeah, we called it VN for some reason. The downside of using AI. At least these were easy to catch. But yeah, AI kind of flubbed that. Okay. And then we have IOVDD1, 2. Something I think is kind of funny about schematics is people talk about schematics as being pretty meaningful. Okay, so 1, 2, 3, 4, 5, 6. But then they do stuff like this where they just like kind of like draw these capacitors all over here. But I think each of these capacitors corresponds to one of these pins. So it's actually not that good of a diagram. It's kind of unclear, but we're gonna have to read the guide to figure out if that's really true. Okay, do we have everything? Okay, so the other issue is it like renamed some of the USB stuff, and then USB DP, which is data plus and data minus, those should be above GPIO 0. So those should be on the right side. This is really tedious, and like we'll probably have a GUI for it, but since it's like a one-time thing, I'm not super gung-ho on automating this in the near future. USB and then we'll remove it from over here. Okay, ADC IO. They call it IO VD. So I'll copy that. Wow, that is a long ADC. All right, slowly getting closer. That matches USB IO VDD for pin 49 or 48. This would be a lot easier in VS Code too. Okay. All right. I think we're pretty good. There's some things that I'm not sure matter. Like our order isn't technically perfect. We kind of like they say one is here. I don't think that really matters because it doesn't change the diagram. Um Yeah, it looks pretty good. So they have these little gaps, these little spaces here to make it a little bit more clear. So we're gonna add those two. Separate things that are um kind of like related. So in 45 left margin 0.2, and then we'll do pin 49. These are all in millimeters. Then pin 48, margin 0.2, and then pin 43. Let's regenerate. I'm gonna save that. You know when there's something like so tedious? I think we have to add some right margin here to keep it away from this kind of wall. We'll do that really quickly. Or we could add top margin. What did they do? Yeah, they had a ton of right margin. In 43. Right margin. Yeah. Even that feels a little cramped to me. Maybe a flat 1. Is that too far? Oh, interesting. Looks like the box size doesn't compute properly. That's kind of a bug. We can resolve. We don't have to like stop what we're doing to resolve that, but that is take in margins when that's a pretty hard one. People mess up that math constantly. It's a place where it's very hard to just be like, ah, that looks good. You know, it's very meaningful, the PRs there. Okay, top margin 0.2. Then pin 47. We want. This is gonna probably push pins off too, because that's also another edge wall. Yeah, it looks okay. Okay, so to fix the width of this guy, we're just gonna manually set the width. Gonna take a couple tries. Back with 5. Actually, that looks pretty good. We can keep it like that. One last adjustment there. Pretty happy with that. Okay. That is probably our RP2040 chip. I don't see anything else I need to add. X in, X out, run, SW clock, SW. So they called this one SWDIO. We'll keep it. We'll stay strict. Oh, why is this given an error? Oh, there's multiple attributes. Oh, that. Oh, interesting. What happens when I do this? Oh, changing too much at once. This. Oh, you know what? I don't think that bug is real. I think I just um verified, not a verified, no bug. Yeah, it's a little crushed in the top left there, but I think it's fine. All right, let's build out the capacitors. So kind of zoomed in on the data sheet, or not the data sheet, but let's read about power a little bit before we put all these in. Power input supply decoupling capacitors. Okay, we can read the inputs. I already did this part yesterday, so we're pretty good there. Yeah, I don't care. Something I've been curious about is I'll ask Claude this. Is a 10 microfarad capacitor typically polarized? Because we don't have great polarized capacitor support. Yeah, 1 microfarad is typically electrolytic or tantalum. Oy vey. Hey, also, somebody on Reddit told me that we should prefer tantalum over electrolytic, so I'm kind of curious about that. Tantalum versus electro. Have less ESR, electro something. Here. Equivalent series resistance. Okay. So that's more relevant for AC, I think. Yo, what up, Copy Multi? How's it going? Okay, I actually think probably those Redditors were talking about analog circuits, not digital. This is a digital circuit. So. Yeah, so let's use our search here. See if we have a 10 microfarad capacitor. What do they typically sell these in? Ceramic. Wait, that seems fine. 0603? Was Claude wrong? Or do these have other characteristics that are really bad? Let's look at the Pico 1. Because the Pico 1, I heard... Yeah, it uses the RP2040. Oh, yeah. It doesn't have electrolytic. I think Claude is wrong. Electrolytic capacitors are kind of big. Yeah, it just says regular capacitors. Yeah, there they are. It's these two big ones. Yeah, we'll just use looks like it's got 0603s here. We'll just use 0603s. Look how many are in stock. Oh my gosh. 6.9 million. 6.9 million. Nuts. Okay. So let's go to the correct project. So yeah, RP2040 module. So this is going to be a module that anybody can drop in and use the RP2040, which would be pretty sweet. Like if you just want to make a keyboard, you could use this. What's cool about the RP2040 too is you don't need a special programming rig. You normally need like special boards or special like adapters just to program, but RP2040 you can program with USB. I was talking to a friend and I was like, oh, maybe I should use these like ultra cheap ones. Have you been a class topper in your high school? I was actually terrible in high school. I did okay in college, but I've never been a class topper. Never been a class topper. And never cared also, importantly. Yeah, I think about this sometimes because my parents didn't seem to care that much. They cared that I wasn't like failing or whatever, but I was third child, so the expectation I don't think was to like do super well. I think they put that pressure on maybe the early children or something, but it all worked out. I discovered the internet. 0603. Also, should be noted, like people on stream a lot of times are like, "Oh man, this guy's a genius." People in the real world call me dumb all the time. You know what I mean? Like, I don't think I think I just know a lot about or about a lot of different things, but you know, anybody can kind of be an expert if they dig in for a bit, I think. There was a little bit of a Twitter discourse around that. Can you become an expert in anything in 2 weeks if you're really motivated? Um there's a feature that hasn't made it in here yet, and I think I might have actually broken this myself. But if you hover over a trace, it's supposed to light up the trace, but I think I broke that in snippets. That's unfortunate. We don't have too chaotic of traces yet, so it's not a big deal. But yeah, things are start getting complicated. So this QSPI, well, all right, let's do power. Power is going to be boring, but this QSPI side is really interesting. We connect it to memory. Yeah, what up, Zoabe? How's it going? Happy Friday. Yeah, let's dig in. Decoupling capacitors. Okay. Decoupling capacitors filter out supply noise, and secondly, provide a local supply of charge that the circuits inside the RP2040 can use on a short notice. Prevents the voltage level from dropping too much, so it's important to place decoupling capacitors close to the power pins. We recommend 100 nanofarad capacitors per power pin, but we do deviate from this rule. And then it shows a screenshot of the decoupling capacitors. I bet this guy is a genius, to be honest. Thank you, Jinpai. I think a lot of people would doubt that. I, of course, know I'm a genius, but, other people would certainly doubt it. Zoeb's like, who? You're not talking about, All right. By the way, this is probably what I'm reading, probably the easiest hardware guide in existence. Very, very simple. Relative to most hardware guides. We'll probably do some hardcore like STM microcontrollers at some point, but this is still Raspberry Pi. They care about documentation. Okay, there's not a lot of room. So okay. So pin 48 and 49 share a single capacitor. Okay. Yeah, that makes sense. They're so close together. The internal voltage regulator has its own special requirements. The internal voltage regulator produces a 1.1 volt supply from an input of 3.3 volts. We simply connect VREG out pin. Let's find that. VREG V out is what we call it. In 45 here. To the DVDD pins. Okay. What is DVDD? On the RP2040, what is ED. Jinpai says, Zohabe, not talking to you. Who the F are you, by the way? That's pretty funny. Sorry. I know I should keep toxicity out of the chat, but that's pretty funny. Who the F are you? It's just a funny thing to say to someone, you know what I mean? All right. It's so aggressive, like for no reason. Like for me anyway, it's like 8 a.m. in the morning. So it's like there's no capacity for anger in my mind right now. It's important to note that while the core runs, okay. Digital power supply. Oh, digital power supply voltage pin typically operate at 1.1. So basically this is an output. Or it's an I think it's an output. Okay, 1 microfarad capacitor, so a little bigger than the 100 nanofarad, close to the VREG and VREG out in order to provide a stable 1.1 V supply. Okay. I don't understand. I think Claude might have been wrong again. It seems like VREG in and VREG out is the 1.1 volt. I don't know what this DVD thing is all about. I should just read. There's going to be a pinout somewhere. I'll open a tab for it. Man, setting up that Cloudflare cache yesterday was so great because, you know, web stuff is so simple. Then you come to hardware land and it's like the land of confusion. Great. Pinouts. This is one of those things where, like, you can get really familiar. People are like, oh, know your data sheet like the back of your hand. The reason you get so familiar is you learn this, like, once, and then you use it for, like, 10 years. We're, like, learning React right now. So this isn't going to have the I/O pins because this is a hardware design guide. So let's find the proper data sheet. Ooh. Pinout reference. And then pin descriptions. So it should tell us a little bit about what the heck a DV is. At Jinpai, clearly you're having a bad day. Don't worry, I'll get back to you being mad at nothing. Am I missing some of the chat content? Like, is it being filtered? How have you guys escalated so far? USB VDD. Power supply for internal USB. That's not it. DVD. Oh, digital core supply. Okay, it is the digital core supply. Can be connected to VREG, V out, or some other board level supply. So is that what they do? So they connect VREG. Yeah. Okay. So basically, this chip has another chip in it that's a voltage regulator, and you literally pipe in some power and you pipe it back out into itself. So they're like disconnected chips inside of it. I guess to save you having to think about I can't wait to do this part. I just want to do this part. It's gonna be so cool. Connecting up the flash memory. So satisfying, you know? That's what I live for, you know? Not setting up like power and electrical engineering stuff, but like, let's put two chips together that do different things. Let's put in the memory, you know? And then let's abuse it somehow. Okay, so basically what the hardware design guide explained is we just need a ton of 100 nanofarad capacitors. And so let's start creating them. I'm going to use the use capacitor hook. Let's just do a quick search and make sure. I'm almost positive these come in the 0402 size. which is very small. Good. Yeah, 0402. Looks like 0603 is also common. There's probably some trade-off there that I'm not aware of. The trade-offs are always subtle and weird. It's like electrical engineering stuff. People always warn you about that. They're like, hey, the real world is complicated, you know? Want you to be afraid of the electrical engineering side. This feels so tedious to type. If I was using AI, it'd be like done right now. Technically, you can edit these schematics with AI, but I don't trust that feature enough. All right, C11. We gotta get C12. We can try some good old C12, C13, C14. I haven't found a way to make it so you don't have to define these, unfortunately, because it's kind of redundant to have to type it twice, but just can't figure out a way to do a syntax where you don't. All right, we've thrown in a bunch of capacitors. We do have a little bit of a representation issue here. I guess we're gonna move these all to the top right. So let's place them down, and then we'll move them to the top right. Schematic X equals, I don't know. This is like roughly 3. You're supposed to be able to drag over, or like drag each schematic component into place. We actually have that feature for the PCB editor, but it's not in the schematic viewer yet. I might work on that today if I get frustrated enough, but for now I'm fine. So schematic rotation 90 degrees. One side of these is always connected to ground. Get a good template going. I was thinking about Factorio the other day, and especially because this stuff is all kind of, I don't know, new. Like everything in TS Circuit is new. It does feel a lot like Factorio. Like we're on an alien planet. Oops. And we just have to like create everything from scratch. uh, okay. So there's C11. I guess C9 should actually be. Okay. Trying to figure out what the right spacing for these are. I kind of like how they display. They will create an issue with this. I like how their symbol looks more than ours, where it's not so wide. um, Yeah, because look how much space. It's pretty. It sucks. All right. I have to give each one like 2 millimeters of space here. Yeah. All right, and a lot of repetition. I would say right now this is roughly equal to like a drag and drop EDA tool. Like we're not really moving faster. We're basically doing data entry. But that's not bad, all things considered, to be matching them at this point. We'll get faster later. Yay. Got our capacitors, it took a lot more room. Make sure C10 is close to pin 44. Okay. Good note. I don't think I can add notes, but... Sevi, are you going to do web stuff in the future? Like non-electronic stuff? I think we go between web stuff and electronic stuff. Do you mean like we do web stuff all the time? Like I guess like in the future of this stream, or because we do both. Today we're basically testing out all the stuff we've built using all the web technology, right? Because we built this entire like snippets website and whatnot. But you got to use your own product at some point. Although, like, you know, I know it's like a little boring to be setting up decoupling capacitors. That's just the way it is. Like setting up these reference schematics. What's really cool is once this is done, you can just say, okay, here's my microprocessor, here's like a motor, and it'll be like a 4-line file that does it all. But you need to build up the foundation. So that's where we get stuck here, you know. I usually stream when I'm doing something like pretty boring too, because it keeps me focused, because otherwise I'd be like, oh my god, it's taking forever. All right, let's see if that connects things together. That did not work. Interesting. I haven't tested this property too much, the decoupling for, so we'll say for now positive equals. Is that gonna do it? Yeah, there we go. It's gonna be a lot of lines in here as we get going. By the way, web stuff, I mean entirely web, like a SaaS app. I don't know, man. I mean, this is a SaaS platform. Like, no matter what, every SaaS app should have some domain specific thing, unless you're a web infrastructure company. Like, so, like, I mean, yeah. I mean, I guess the answer is like kind of, yeah. Like, I'm not going to build a 100 like no electronics involved application, if that's the question. Because like, you know, this is a startup. Daniel, what's going on? We are working on an RP2040, which is a Raspberry Pi chip board or module using TS circuit, which is a way to create circuits with React. So we're doing some tedious bits, but you know, it's how you got to do it. I could do this a lot faster if I was using VS Code, so I am regretting not working on the CLI a little bit so that we could have done this in VS Code, but okay, we're gonna get a bunch of wires in a second. We recently have done a ton of work on the wiring algorithms, so I'm hoping that these all come in very clean. Do I have too many? C13, C15. 1, 2, 3, 4, 5, 6. I wonder what... I don't know where this one goes. I'm just going to leave it blank for now. Let's see how this wiring looks. All right. It's not bad. It's kind of better than I thought it would be. This looks a little dorky. What's going on here? I think the stroke width on the background cover is totally wrong. That's really interesting. It's totally wrong. Okay, I'll have to look into that because it looks a little broken. But, you know, it's minimally readable. You have funding for your startup. Yes, we are funded. We haven't announced it yet, though. Yeah, it's a pretty goofy way to wire this up. Like, it's very unnecessary to have all those wires, but it works. I also don't like how it's wiring through this. I can make a quick note on that. Although it's a little tricky. That's going to be a bigger issue than people expected. Don't wire through manufacturer labels. This requires moving the manufacturer labels as in a schematic text or output rather than inserting inside circuit. Yeah, we also run a bounty program. So speaking of funding, we give away small bounties for each PR or for many PRs, not all PRs, but it's kind of how I am guiding the organization towards the things that like are most likely to bring us money. But yeah, we've awarded $280. I think we've been running this program for not even a month yet. And then we've got about $600 of bounties outstanding. I'm keeping my eye on the Discord too to see if anybody wants reviews. Yeah, nobody posting yet. Yeah, I'm kind of curious here. So there's 1, 2. Sorry, guys. I have one capacitor unaccounted for, so I'm gonna spend 5 seconds figuring that out. 1, 2, 3, 4, 5, 6, 6. 1, 2, 3, 4, 5, 6, 7. So there is some pin I don't have accounted for, and then I also remember them saying 48 and 49 share the same capacitor. So is that the one we're missing? Where's 49? I don't even see 49 here. Also, this is kind of bothering me. That's a circuit to SVG issue for sure. These pin numbers. It's too much spacing on the top pin. Looks like I maybe have one review. Whoa. Get a Nas killing it over here. He did pill shapes. Yeah. I've wanted pill shapes for a while. Oh, interesting that he removed this file. That's fine by me, though. Oh, type improvements? Wow. Damn, a lot of math, so I'm not gonna check this math. I think you basically validated it with your screenshot. But that looks great. Shit. Cool. GG. Good job. I like a NAS. It's always coming in clutch. Those fixes. Okay, hardware design with RP2040 KiCad files. Let's open it up in KiCad, figure out what's going on. Oh, somebody else wrote a design guide. Very interesting. What are you saying, sir? Component cost and the number of parts. Yeah, people complain about the number of parts on the RP2040. We switch to. See if we can find the microcontroller. Oh, I don't have search, dude. Down here. You switch to this one. Ooh, ARM Cortex M0. Ooh, fast. Oh, and it has USB? But it's $1.33. Versus the RP2040 is it's about $1. So why do you like so much? I do love this. I like it when chips are a little bit chonky. It's a little bit chonky. Bounty $10. I can't tell if that's sarcasm or not. The bounties aren't supposed to like pay somebody to work full time, but they are supposed to be like a nice like tip. You know what I mean? But yeah, there's as of 5 minutes ago, $640 of outstanding bounties. And if you use AI, AI can probably do 10-20% of them. If you monitor the AI, like if you don't not do anything, probably 50%. Just kind of got to check its work. Really, that's more or less like why I don't just use AI for them. There's a lot of things I just use AI for because it's faster, but with visual things, it's almost impossible to. All right, why does he love this so much? Sorry, I'm just curious now. Because, you know, like we're reading all this stuff on this data sheet. It's like you really do invest in a chip for like 10 years. You literally choose a chip and you go, yep, I'm going to use this for basically forever, learn everything about it. I don't know. I'm not going to go that far. But it is cool, like just like at a glance, like no crystal needed. I think we have to have a crystal. Am I wrong? Power circuit. Crystal. Yeah, you need a crystal. Yeah, so you don't need a crystal for it. So that's already like a bunch of things you don't need. You don't need flash memory. We have to put a flash memory chip on ours. It has USB. Yeah. I mean, it's a little bit. It's like 30 cents more, but yeah, I mean, it's hard to justify all those things. How many ADCs does it have? 87 fast IOs. So like if you're not familiar with chips, STMs are kind of like the dominant chip, and RP2040 is relatively new entrant. But the cool thing about Raspberry Pi chips is there's only like 2 or 3. So there's not so many versions that you have to worry about like picking a version. They try to make them really general purpose, but this does look really nice. $12. Oh, it only has 1 ADC. All right, whatever. Okay. Sorry, little detour. Okay, yeah. Tell me a little bit about the hardware design. Um, it's interesting. He recommended this push button. What is that push button? Ooh, cute. You have to have a push button because when you use these chips, you have to push like just the convention. And I think the only way to really do it is you push a button and then you plug it in with USB and then you copy a file and that file becomes the bootloader, which like basically tells it how to stuff. Um, oh, interesting. You can contact me on Discord. Should literally just pay this guy to make the module I'm making right now. Component choices. Trust me on these, please. The AMS, this is what I'm using. Ooh, ouch. I feel targeted. Copy multi. In an hour, it will be Saturday. I am living a day ahead of your timeline. I'm a time traveler. Yes. Yes, that checks out. Time zones. Okay, so the AMS 117 has a high quiescent current and has a bad minimum load. Needs large caps. I feel a bit hurt because I already did this part of the circuit. So quiescent current, I believe, is the current when it's not doing anything. Quiescent current is the current drawn when it's powered on but not doing anything. Yeah. Sad. This guy does seem pretty smart, though. You know, he's definitely on my wavelength. This is why when I was saying, you know, interesting. It's cheap. It's 3 cents, and there's 23,000 in stock. And he also said, trust me on this. You son of a gun, I'm in. You son of a gun, I'm in. All right, recommended to Crystal. More than enough flash for any keyboard. What is going on? Is he building keyboards? I didn't know anybody built keyboards with RP2040. RPad. A macro pad using the 2040. I feel like this is like a intro project for a lot of people as a macro pad. Anti-sleep dealer, sleep dealer get club. This guy's pretty cool. Sleep dealer. I'm Kalia. I like this guy. Steam. Big Factorio fan. See, I've never heard of Deadlock, so now I'm just gonna take this guy's recommendations here. I feel like it's kind of like weirdly intimate for me to see games people are design for. Looks like he's designing a bunch of keyboards. He or she kind of looks like a she from this photo. Very interesting. Wow, currently getting bachelor's in computer science. Damn. Damn, I should hire this person. All right. Making a note. Bringing it over to my second monitor. Making a note. That's pretty cool. Sleep dealer. Good name, too. Good name. Okay. You know what though? They did say just trust me on this a couple times, and now that I know they're a bachelor, student, possibly not out of school yet, I do have some skepticism. Okay, push buttons. Okay. So they recommended Flash. I haven't picked Flash yet, so that's fine. This really hurts because I picked this out and was very proud of myself. This is the most popular voltage regulator on JLC for 3.3 volts. So, anyway, we'll switch it to this one. That's fine. Triggered, but that's fine. I can't accept that someone is better than you. There are many. There are dozens of them. Let's import this part. Man, I already made this part of the circuit. So unfortunate. But we'll just queue this up to switch it. If you're not trusting people on the internet, then what's the point? What's the point of all this? You're not going to blindly trust somebody's GitHub on the internet. I mean, they have 200 stars. Do I know Mark Lowe? Yeah, I know of him. People keep mentioning, I think I just figured out this bug where there's extra pins. It's because of these friggin' silkscreen paths. God, it took forever to figure out. All right. I've been just like, why are there extra pins? Been the silkscreen paths the whole time. Silkscreen paths cause extra pins in schematic view. Yeah, he's like a SAS guy. How does JLC do the schematic for this? VSS, V out, V in. VSS stands for V voltage sink, I think. I don't know what the second S is. But yeah, let's clean this guy up a little bit. We'll say schematic port arrangement. Left side, we'll do I think VSS VN. Maybe V in VSS. So that ground on the bottom. I really need AI. It's so hard to type without AI. It takes so long. I'd love to integrate Copilot into the online IDE too, but I think it would take too long. I think it's worth the adventure. Some adventures just aren't worth it. By the way, is this your first startup? This is my 4th startup. I've done many startups. Okay. Save. Why does it seem like my first startup? I'm offended. We'll call it regulator 3.3. Yo, Rohit, what up? How's it going? All right, we'll use this later. I don't want to redo my circuit right now, even though somebody on the internet told me I was wrong. Look at that call out. How embarrassing for me. Okay. So we use that. C9002 is a great basic part. Okay. We're not doing the crystal yet. We're still trying to figure out power. Oh yeah, I forgot. I was looking for the KiCad files. KiCad. Where are the files? Because then we can pull it up and figure out what the heck's going on with these caps. Minimal KiCad. Great name. Minimal. Who is making these folder names? Okay, so we'll say KiCad RP2040 reference. And let's open this guy up. Ooh. Fourth startup, Billionaire Sevi. Yeah, I wish. What are the other startups you've done? My first one was called College AI. My second one was acquired by Cloud Factory, but it was called Wayo AI. And then my third is this company called Seam. That was my last one, Seam.co. So these guys are still going. And then, yeah, fourth is TS Circuit. Yeah, you don't become a billionaire just by making a business. It turns out the business has to print a lot of money, and it takes a really, really long time. Brother, recruit me in your startup. Do like 50 bounties, you know? Do some bounties. Or get that portfolio up. You can DM me like a portfolio on Discord if you think your portfolio is good. But generally, I'm gonna hire out of the contributor pool or people who are just like unreasonably impressive. So there are a lot of millionaires in the US. I'm not a millionaire, but there are a lot of millionaires in the US. It's not even a big deal. It's 8.5% of the adult population is millionaires. If you see somebody on the street, there's a 10% chance they're a millionaire in the US. And to retire in the US comfortably, you have to have $2-3 million. So there's a lot of millionaires in the US. It's not a big deal. And I am still not one of them. Okay, this is the example board. Well, I'm so excited to talk to that Shadow, or what is his name? Sleeper or something. That'd be awesome. Seems really cool. I like what he's doing. Hopefully he's good at TypeScript. If he's not good at TypeScript, he or she, it'll be rough. Be tough. I think, I'm no KiCad expert, but I think I can pull up the schematic at the same time as the PCB, and then I can click on things and maybe figure out where things are. So I don't have any chance. Just go do some bounties and then get like your 10, 20 bucks. And then what are we making today? We're trying to build this, like literally what I have on screen. This is a RP2040 reference board. We're basically trying to build this. So a circuit is represented in two parts. Part one is the schematic and part two is the PCB, this is like what it actually looks like in the physical world. There's also a 3D view. I've actually never used this in KiCad, but let me see. There's a 3D view somewhere. That's supposedly pretty cool. View 3D viewer. Yeah, there we go. Yeah, KiCad's 3D viewer is pretty cool. People keep posting screenshots on Twitter. It's kind of better than our 3D viewer. Sad face. So like, yeah, we can see the capacitor labels here. Oh man, I really got this in a weird orientation. So U2, this is probably the flash memory, U2. J1 is the 117 that I was told not to use. And then it looks like that's the USB port, but it looks like for whatever reason it's not there. I am changing this design a little bit. It uses a USB micro connector, so I tried to use a USB-C. So there's a good chance it just won't work because I messed around too much with that. How much did you sell your old startup for? I'll just say the only startup I sold was Wayo AI, and it was not a particularly lucrative acquisition. So I'll just leave it at that. Yeah, just because so I guess people don't know this outside of Silicon Valley, but like just because you sell a startup doesn't mean you actually made money. A lot of times you're just trying to pay back your investors. So yeah. That's the real world for you. Why is the cam shaking so much? Is there an earthquake coming? It's because I'm shaking my leg. All right. So we can kind of start to identify which capacitors are associated with which pins. We can also make it so that our schematic is accurate, like more accurate than their schematic, just to keep things clear. Because otherwise I'm gonna be pretty confused. I don't have Shadow Sleeper to guide me in the stream, guiding me. It would be great to get them in the stream though, because they would definitely be like, you know, why don't you just use KiCad or something like that? Okay, so C13 is connected to pin 10 according to KiCad. So what do I have it connected to? Oh boy, that's hard to follow. Pin 42. Let's just maybe I do these almost one at a time. We comment this out. Comment this out. Let's just do it one at a time. So pin 10. What is pin 10? Oh man, all of these pin labels look like garbage. Something must have changed, or maybe a setting I gave it messed it up. Or yeah, it's kind of hard to read. Okay, so this is 45, this is 44, this is 1. So IOV. All right. So that capacitor is accounted for. Wow, why are these pin labels so messed up? They weren't like that before. As if you need a margin 10 pixels. I don't know what that's in reference to. Sounds like a good sounds like a slam dunk though. Like I should be upset or something. I saw one guy sold a start for 10K. Like it used AI to make a landing page for your web app. Yeah, it sounds really boring. Doesn't surprise me. You are creating Raspberry Pi. Not really. The RP2040 is not as capable as the Broadcom processor on the Raspberry Pi. And you would know that, Rohit, if you were in the stream 30 minutes ago when I talked about Broadcom on the Raspberry Pi. This is the RP2040. Losing my cool. It's too early for that. I'm just kidding. All right, what do we got? Yeah, sorry, this sucks, but you know, look, if I order this board and it doesn't work, I'm gonna be a sad man. So why not just get it to work? The other thing we can do, instead of like tracking down all this stuff right now, is like this is pin 33, so I can literally just type pin 33. I should be able to, hopefully. Never mind. That is apparently broken, so we have to figure out what pin 33 is. I think it's IOVD4. Wow, that's impossible to read. $43, $45, $42, $43, $33. Yeah. Okay, I think I did it right. I kind of want to fix this. This is really bugging me. Why are they so far off? When did this happen? How did this happen? That's R5. Man, why is this so hard to read? Let me see if I can get rid of some stuff here. No, I need that. Can I move this to the top? It's on this layer. Oh. Whatever. Okay, I think I actually can read this. C14 is the middle one. Is that one of the things? All right. We'll do C4. You gotta do it once. You know what I mean? You gotta put the pins together at least once, and then after that, we can just use this module forever. 22. Okay, what is 22? This impossible to read thing. I think 22 is 33. Ah, fuck me. I already have that. All right, we're gonna fix the pin levels. This is unreadable. Oy vey. So first thing, we create a reproduction. So we'll add a schematic test, RP2040.test.tsx. Then we need the code that produces this. Then this function. So we copy this. Yeah, that'll probably work. Oh, feels so good to be in VS Code again. Yeah, test RP2040 schematic. Kind of forgot how to write these tests though. We gotta look at another test. Circuit, get test. Yeah, low startup acquisitions are super common. People don't talk about it. They just like to say, "Oh, my startup was acquired," and then use that as a credential. But most startups not acquired for that much. Just a way of getting out of the game. Okay, so I think we have to say create schematic SVG snapshot. Convert circuit. Yeah, there we go. That's why I need Copilot. Yeah, we'll do that. We're also going to add some options that I like for debugging. So we're going to say label the grid and yeah, label the cells. That will help me debug. Okay. So let's see. Got some big complaint here. Do not export from a test file. You gotcha. All right, we're good. So this should generate a reproduction. We test it. Possibly out of date dependencies here. Oh, I need a board. Yeah, right now you have to put every component on a board. We'll probably change that in the future. Nice. All right, so we got our snapshot. We open our browser. We can see what that code generated. Oof, oof. All right, so weirdly enough, it looks fine. We're just gonna anycast that because it's being annoying. Brother Severin, are you the only employee of your company? Like in the US, yes, but not like we have contract. There are contractors which, you know, It's kind of like an employee. I can't hire people outside of the US. To hire people outside of the US, you have to have an entity in those places. But there are people who work full time. But it's mostly just me. It's not like this whole project is only really 7-8 months old. What's up with all the brother talk? I'm always wondering about that. Everybody's like, bro, brother. Hire me as a motivator. You want to be a professional motivator? You know who I hire as motivators? All the contributors, because nothing gets me out of bed like seeing somebody flubbing some code on a PR. I get so mad I run to my computer and I go, why don't you write a test for this? Because I know the code is wrong. Tests. Proof that you actually saw what your code did. Why are these pin labels not fucked up? They're not fucked up here either. So they're only messed up here. We don't have a reproduction. I don't know how to reproduce this. Or we don't have a easy reproduction. This has a bunch of imports and crap, so not a very easy reproduction. There is this. The fact that it's inside of a group subcircuit. Still no reproduction. Why? You messed up. We had something fun happen today. I don't mean to call anybody out, but somebody was asking for a call. They were like working on a GitHub issue. They were like, I think I understand this issue, but let's hop on a quick call to verify. I'm like, psh. You don't get how this works, do you? You don't talk to me. I talk to you. I live stream to you. No, I do hate meetings though. All right. So, a couple theories on how we can reproduce. We can gradually modify the circuit until the issue disappears, and then we'll have a more minimal reproduction. So the traces. Oh, it didn't. I just removed all the traces though. Oh, I guess these traces are. We'll move capacitors. All right. Oh, they're fixed. What? Am I crazy? They're messed up when you have a trace going to them. Are they more messed up now? Yeah, they're starting to top the edge. Then I remove the cap and they no longer top the edge. They're just before the edge. Still not great. The spacing could be better, but they're definitely not topping the edge. Rohit, Sevi, bye. I don't know what B high is. You are a really fun guy. Why don't you grow your YouTube channel? I probably will do YouTube videos once we actually start making circuits. And then we'll do like unboxings and fun stuff. But right now, like you guys can tell, like we're not doing like the exciting part of building electronics. We're doing like foundational stuff. It's not as fun. So once we get that far, we'll do more. So strange. Okay, but we should be able to reproduce now. I just need to create a capacitor and add it to the circuit. So we'll do use capacitor. I need to copy over the code. Or maybe we'll just insert the capacitor. And then we'll say some traces. Bye means brother. Now on, I'm gonna call you Sevi Bye. Okay. It's a lot of brother lingo, is what I've noticed. You know, we had a whole like anti-bro culture movement in San Francisco. It feels a bit odd to me, if I'm gonna be honest. Because we had the whole anti-tech bro movement. I guess it's coming back. How do you pronounce that? Bye? Very interesting. Yeah, I think I need to get this capacitor back into the same position that it is. So let's see. We gotta copy it. For graphics programming, neuroticism is like good. You know? Because you wanna be super anal about those details. Wonder if anybody has done a PR today. No PRs. Very disappointing. No PRs on Discord. Wow, no reproduction. Disappointing. Man, I don't know what's going on. Hi. Just trying to pull in random things. Could not find net selector. Oh, whoops. Yeah, this should just be net ground. A little bit of a weird syntax. Yeah, they're still not getting pushed. How the heck are they getting pushed? Let's look at the code itself and see what's going on. Create SVG objects or probably like schematic pin numbers. Pin number text. Oh, interesting. It could be schematic port positions changing. Okay. That could be a cause. Distance from edge. Okay. Hmm. I have a theory it's related to like overlap. Why are they bad right now? Ugh, and they're all bad. They're all like equally bad. They even don't look quite the same right here. I know this like seems insane, but like when you have an issue like this, I mean, it makes life so much harder. It doesn't look the same, the spacing. It's totally different here versus here, so something's happening. Yeah, so here it's fine. Does it just get worse for each? Okay, so the USB-C component. The other thing that's kind of interesting is the USB-C component really shifts the window of like there's a larger bounds. And when the bounds, yeah, okay, there we go. So when the bounds is normal, these appear in the right place. But when you shift the bounds, it's worse. And the capacitors all switch the so like as I make that bounds more extreme, shift that USB-C port way to the left, the pin labels get more and more off. Okay, so the issue is actually something to do with bounds. Graphics programming. All right, so let's try shifting this to -100, 0, and see if we get a reproduction. We're gonna have to do a lot of zooming. Ooh. So our capacitor's way on the right. Yeah, there we go. Now we've got a repro. Just sucks to look at because it's such a big. There we go. All right. So when the bounds change, the pin label gets worse. Why would that happen? How could that be happening? The only thing I can think of is this rotate transform. But that isn't in effect for all of the pins. So that wouldn't explain why some of them aren't set. Font size, text anchor. Hmm. There is this weird little line, but that's in pixels, so it shouldn't have too much effect. It's also only top. We need something that would affect all of them. Move the pin number halfway to the edge of the box component so it sits between the edge and the port, exactly in the middle. Let's log this really. I'm curious if I can see a pattern. So let's just look at the, which one can we look at? Let's do a table. That'll be easier. Oh, is by Bay? Is that what it is? Is it Bay? That didn't really help. Yeah, these are still kind of difficult to read and get. I'm curious if the bug is in circuit to SVG or core. And a very quick way to verify that is just to log out the schematic port positions and see if they change if we trigger the bug. Hi. Okay, so these are the positions before. That's pretty easy to read. So now let's look at the positions after the bug is removed. So we're going to remove the bug by removing the capacitor. And they look the same, I think. Ooh, however, I have this terminal output that's not great. Here's the previous one. Let's do this. Okay. Yeah, lots of 2.6, lots of negative 2.6. They look about the same to me. I don't think they're changing. Good night, bro. Sleep time. Good night, Rohit. Have a good one. 4.15. Yeah. Hmm. All of this text is moved too. All the grid text is offset. I don't really know what this transform origin thing does. I've not understood this. I can't remove it either. I don't think I can remove it. Hmm. Those all look good. The unit vector should always be 0 or 1 for each dimension. All right. I think maybe the RP, if we can reproduce with a simpler chip, I think that'll help us out. So let's do, I don't think we need traces. My intuition about this is right. Should be able to do U1. Say, I don't know if this will work, but let's try to create like the simplest chip we can imagine. Yeah, something like that. Okay, that, oh, maybe worked. Okay, yeah, so that's a very, very simple reproduction, so that'll be helpful. And then I almost want to get rid of capacitor as well, because it kind of has its own schematic port, so it'd be really good if we just didn't have anything interacting with this. Is there any way to increase the bounds? I think we need something to increase the bounds, so I think we need at least one other port. We'll just create a second chip. Can literally be the same thing. We just need it to be way to the left. Yeah. A little tricky because it's less detectable the further it is, but the schematic always tries to be a square. So, yeah. But now it's very detectable when it's 100 away. Okay. Transform none. Okay. That's fine. You can look at its computed layout. There's like nothing. It really just feels like the position is being calculated wrong. Okay, so negative 0.8 is what it's calculating for the center where it's supposed to base itself. Negative 0.8. That looks right. That looks like that's probably negative 0.8. The only way we know for sure is if we created a better grid, so we can do that. Instead of a grid that's spaced by big cells, we'll space it by 0.2. Oh, that didn't work. Huh. There must be a bug. Okay. We'll mess with that. Anyway, that's probably 0.8 right there. Seems pretty close anyway. We could get rid of this for now and see what happens. Oh, interesting. That did kind of move it back into position. I think probably the issue is we never want to do math in pixels. Never pays to do math in pixels. Because I think you can't trust it because of the way the view box works. So So we'll change this to edit that distance in millimeters. Then we'll have to figure out what this should be. It's probably really low like that. Okay. I do this backwards. What was it before? Oh, right. The y-axis is going to be inverted. Yeah, which makes sense. So we're moving it up. That's the other reason to not go to pixels early. Yeah, that looks way better. Yeah, I don't know. Is this side okay too? That's a weird one. I don't even know if I'm gonna commit the quote unquote reproduction because it's such a jank SVG. It's so long. And the solution is pretty simple. But anyway, that's the fix. Poof. Okay. Yeah, let's just remove the test. I don't see too much value in it. I kind of like the idea of, yeah, you know, we could just add a test for the RP2040, but not do a reproduction just because it's a cool test to have. Fix pin number text getting offset with large bounds. Okay, so the reason I always do a PR for this repo or any snapshot repo in particular is you're going to see if you broke something else. So Hape says Mark Lowe sold 1 star for 10K and it was making an AI for your website. Yeah, I mean, that makes sense. It's a very boring idea. I don't see tons of potential there. I mean, there's a lot of people doing it. I mean, unless it was like, I don't know, it was like really killing it, but I don't know. I'm like generally not that like I get that everybody's playing in that space, but they're so boring to me. like a lot of like the like low hanging fruit of web development is so like it's like do something harder. Do something that takes a year before you can even have an MVP. People are like, "Oh, ship your MVP in a week or whatever." And I get it. Like that was a dominant mindset for a while and stuff, but you know, the low hanging fruit, just boring. I don't know. I'm also like later in my life, you know what I mean, than other people. So if you're doing your first startups or whatever, you know, more power to you. By the way, I don't know if 10K is a lot of money to you, but 10K is like nothing. Like in the US, like for a developer job, you would make 10K and you would make 10K every 2 weeks or something. You get taxed a lot on it, but you would make 10K every 2 weeks. That's not that big of a deal in the US. US software developer salaries. You know, I wonder if instead of adding this, I wonder if I can just do update circuit JSON. That's why they call these things micro SaaS. Yeah. I don't know who's buying it. You know what I mean? It's just gonna die. I don't think you'll even get ROI. You're really just, yeah, I don't know. Maybe some people get ROI. I don't know. The thing is like to grow a business, you have to have something unique, you know, unless somebody is pawning off the business. Honestly, at 10K, maybe somebody is just pawning off the business. The US is too expensive as well. US is very expensive. Especially San Francisco. A lot of US people complain they can't get jobs right now too. So, in my opinion, they just need more portfolio work. But I get it. Tough job market. Okay. All these snapshots look fine. Essentially, there were minor adjustments to their calculations, and that's why they appear in our snapshot, but like it's basically undetectable. I'm very happy about this fix though. That was pretty annoying. Mark Liu is living in Thailand, so it's a great deal for him. I don't know if it's a great deal for anyone. Dude, the lawyer fees on an acquisition, if it's a real acquisition, it's probably not. Okay, so first of all, in the US, like, I don't know, US and probably everywhere, an acquisition is like an actual like thing. And if you're acquired for 10K, it's like, it's just an asset buyout. It's not actually an acquisition. I don't even know if it's worth being that pedantic. It's just such a low amount, dude. If somebody sold their startup for 100K in San Francisco, that would be considered a failure. $100,000. Somebody sold their startup for $1 million. That 99% of the time would be considered a failure. If somebody sells their startup for $10 million, 90% of the time, I would say 50% of the time, no, I would say 70% of the time that would be considered a failure. If you raised any amount of venture capital, 100 million, you start to get into like half the people are disappointed, half the people are happy. The app is so basic. Yeah, but it's not even worth your time, dude. The lawyers to look at an acquisition would cost, you know. Yeah, like lawyers get paid $400 an hour, you know, in US. So, you know, like crazy. I don't know, dude. It's just not like a notable deal. You know what I mean? It's like not at all a notable deal. Lots of people make 10K doing lots of stuff. Like, I don't know. I mean, I like people who publicize that they're doing stuff in startup land, because it just like in general like spreads knowledge, makes it more approachable, makes people like want to get into it. So I'm happy about that. Makes people more savvy. But like other than like a nice case study or like reference, like 10K is, it's almost like something you would do for a video. Do you acquire .com, open it, and listed his startup there? He listed his startup here. I don't know what you mean. Um okay, we're definitely jamming, and I have other stuff I want to do. In particular, I want to make sure these updates get into snippets, but I should break for lunch or I'm going to be hungry. I might do another stream later. He listed his startup on acquire.com. Yeah, I've heard of this. I've heard of this platform. So better than doing an acquisition is just to make money. Just make money. Make a business that makes money. And don't do something that's like super simple. Do something that's actually like nuanced and niche. You know what I mean? Don't try to appeal to everyone. Appeal to very specific people. Yeah, I don't think, man, dude, real acquisitions don't happen on acquire.com. Not yet, anyway. Maybe someday. Maybe someday. I don't know. Somebody finally listed a PR. Dependency update. This will get us our 3D view for our RP20. So when we look at the 3D view for the RP20, currently it is just showing copper. No 3D model. So we need to... No lawyer, nothing. Bro, what is your IQ level? I don't know. I haven't done an IQ test. On acquire.com? I don't know, man. It's just not a good outcome. I don't know what you want me to, what do you want from me? It's just not a good outcome. 10K for almost anything isn't a good outcome that you put blood, sweat, and tears into. Unless you're able to reliably do it every 2 weeks. It's not worth it. Like, build a business that makes money. It's much better. Anywho. Like 10K, dude, like you do contract software development and a project is going to be more than 10K. I don't know. Okay, anywho, I'm going to break for lunch. Thank you all for listening. Definitely join the Discord. On tscircuit.com, there's this little chat link at the top here. So that's how you can get on the Discord. But that's it for now. Thanks for joining. You need to update the dependency of JSCAD electronics. I think we did it in us. Oh, you mean on snippets? Yeah. No, we do need to, I'm going to probably do a bunch of updates because I also need a circuit to SVG update. We also have auto updating. So hopefully that kicks in. Yeah, it's already kicked in for circuit to SVG. So I think if JSCAD, does this repo use JSCAD electronics? How does this work? Yeah, so if you want snippets to auto update these dependencies, what you have to do is go to the renovate config. There's so many configs, and then you just need to add it here. We can say JSCAD electronics. Because it's not at TS Circuit, it won't do it automatically. So when are you gonna stream after this one? I'm not sure. Maybe later today. Yeah, depends. Yeah, maybe later today. I'll keep doing stuff. I might try to do some of the more boring parts of the RP2040 module. Like get these capacitors out of the way. Yeah, I have some notes on what I want to do, but yeah, it's just a ton of stuff to do. I want to, I'm going to Taiwan in a week. So I'm going to be in Taiwan for a while, so I won't be able to do unboxings. I might be able to stream from Taiwan. I'm not really sure. I'm not really sure about a lot of things like my internet or where I'm staying and stuff like that. But I'm going to be in Taiwan for about 2 weeks. So I won't, basically, I'm not going to do an unboxing for like a month because I won't be here. I have a virtual shipping address. So I'm going to be using the virtual shipping address to collect packages. So I'll have a ton of unboxings, but we want to get tons and tons of circuits on my desk when I come back from Taiwan. So the goal is to do like some pretty gnarly software stuff in preparation for that. Get some microcontrollers working, stuff like that, by the time I get back. And hopefully integrate free routing as well. But anyway, that's all for now. Thank you all for joining. Definitely join